Hey guys, welcome back to the Zenith Stratosphere porthole television restoration project. I hope to wrap it up in this installment. When we last left off, I discovered a mistake I had made that was making the image very unstable and unwatchable, and then discovered there was an open resistor in the tuner. Fixing both of those defects got a nice image on the screen. Since then, I went to town cleaning up the rest of the chassis, including taking the cover off the high voltage area here. You see it's a pretty conventional looking flyback for a late 40s black and white television. It's a high voltage rectifier sitting right on top of the filter cap. I did repair the IF can shield that had been busted off. Still lots of dent in the side as a little reminder of what happened to it, but I got it reattached. I took out all the tubes so I could really clean up around here, and I lubricated everything. It still takes a bit of force to turn, but things are working better. I still have to fix the dial string. I did find a dial stringing diagram in the Sam's photo fact for it, so I got some idea how that goes. It's pretty similar to this. 2 loops around this, a spring, and then it attaches just like that, but in this case it goes between this and this guy. Before we do that, sound. We haven't heard any sound come out of this yet. I just finished going over the sound circuit. This is the sound IF down here. It's the sound IF on this side, video IF on this side. So let's pop the tubes back in, fire this back up, and hook a speaker up to it, and well, see what the sound quality is like. Speaker would connect up here. Uses a 6V6 single-ended output tube, Class A operation. Okay, I got all the tubes back in, and I have a speaker rigged up. That's not so good though. There is nothing, no indication of sound whatsoever. So, one possibility is that we have an open output transformer. Otherwise, we'll start tracing our way backwards. So here's our output tube, detector, and then the IF stages, so we can do some injection. First, I want to just try doing a simple test to see if we can hear some hum. Just gotta figure out which of these pots is the volume. So one is contrast and one is volume. I think this is volume. That's good. Yeah. Oh, there we go. Just need a little kick to wake up. Okay. You know, the joy of split carrier sets. So, good image, no sound. We get our tone, no image, so we may need to align the sound. Before I attempt a sound alignment, I want to go over the circuit, in particular checking all the resistors, and while doing so, I think I found the source of that pop when the sound came back. This tubular capacitor was bumping up against this 22 meg resistor, which is in a very sensitive circuit. There's a 15 mega ohm resistor back in here. So I just pushed this out of the way. They were just grazing each other when I was measuring the resistance. This 15 meg was measuring, well, it was shorted against this, so it was measuring 22K. Now it's back to 15 meg, and this is pushed well out of the way. Now, continuing on, real common problem in sets from this era, the cathode bias resistors, the sub 100 meg resistors, whether in the audio or video. So we got a 68 ohm here and a 68 ohm over there. They're measuring more than double what they're supposed to be. So that guy's going to get replaced. And there's another one down in here. That sets the bias on those tubes, and it will affect the gain. Now for the alignment, they say you need a special tool because there's dual slugs in each core, but you only go through the top. But I think that's just a hex tool that has two different sizes. So I think I'll have a tool that will be sufficient. So we're talking about this and this and this. They're all tuned to 21.3 going all the way here. So if you're more familiar with an FM radio where it's 10.7, typical TVs from this era use 21.3 or 21.25 is actually a little bit more common. And then there's a ratio detector there. Now the instructions show using a sweep alignment generator rather than just peaking it to the frequency. So I'll try to get something going with my HP 8662 and my 2465 scope. Just need to get a bunch of cables and hook everything up. Okay, I got my 8662A sweep generator going between 20 and 22 megahertz. Got hooked up to my scope, my TAC 2465B in XY mode, which honestly I haven't not used this conjunction of test equipment before, and I'm bummed out that the Z-axis modulation doesn't seem to be working on the scope for the markers. So this has 5 programmable markers. So I have one at 21.3 because we're trying to get a waveform that looks like that. And I should be getting a bright dot at 21.3 on here. I'm not. I checked the output of this for the Z-axis modulation and it is working, but this doesn't seem to be responding to it. But we can push this button. When you push it in, where that dot stops, that's the marker frequency. So I adjusted my scope so the frequency of interest, 21.3, is right in the middle, right at that cross point. My scope probe just came off. And kind of neat that they gave some provisions for doing sound alignment. This is where you hook your scope probe, your Y-axis output for this procedure I'm doing. And for another one, you hook it up to that guy. So anyways, so we are off. So it's supposed to be about here, but instead it's down there. So we got to shift this over a couple hundred kilohertz to the left. And it should be, so we're injecting there, we're measuring there, we're going to adjust this coil from the top. And for the tool, I figured out that you need this type, where you have a hex end that's a little bit larger than shaft, and then there's an upper coil and a lower, upper slug and a lower slug. And you do adjust both of them. So it's going to be this can right here. See. Oh yeah, we can move that over. That's one slug. Other one. Oh yeah, getting there. Got to go back and forth between the two. They affect each other. Get there. That would explain why the sound is so off. Just about got it. Alright, I'll do the same for the other two stages. Now I'm working on the discriminator S-curve. Should be centered on 21.3. It's right in the middle. I got it crossing over right in the middle. It's pretty symmetric. Should be looking like that. I think we are pretty good, certainly a lot better than it was. So let's give it a try with a real signal going through the antenna. Alright, so how do we do? Decent picture. Tons of volume. Alright, I think we got that licked. Next up, we'll try a over-the-air converter box. The fine-tuning dial cord was actually a rather easy repair because that was present and it was fine. The spring had just come loose. Probably because the grease had dried up and it was putting a lot of force on it when somebody was turning it and it popped off. But I got everything lubed up, so it is working just fine. I have an over-the-air converter box hooked up now. And we have fantastic sound. I'm not going to worry about the image too much until I get the full-size pitch tube reinstalled, because the focus coil on the neck of this is fighting the autofocus CRT. There's plenty of sound now.
He's going to burn after this one. He'll go cuckoo. Yeah, there's a lot of that going around, right? Brother? I ain't your brother. Oh, come on, B.A. It worked, didn't it? Murdoch's blood might even...
And there's also this local oscillator adjustment. I think I could do a little bit better with my antenna connection too. I just have things kind of clipped into place right now. So we'll worry more about that. I'm going to get the full-size CRT reinstalled now, and I'll go through and make all the final adjustments with the vertical and horizontal linearity and drive control and all that. There it is in porthole mode, just to go up a little bit higher and have a little more height to it. And in regular mode.
In dark times, we need heroes. We're investigating a death. Sounds suspicious.
Similar with the brightness and contrast, because this isn't the real CRT. So I think the reason the brightness has been, even with the brightness all the way down, it's still kind of bright, is because this little tiny 5-inch CRT doesn't draw as much beam current as the full-size 16-inch CRT. Also, the deflection isn't as much, so it's staying longer in a given small area of phosphor than when it's a much larger, the electron beam is going to be staying in one area for a shorter period of time, so it should get dimmer. So again, I'm not going to worry too much about the brightness until we get the full-size CRT installed. Let's get that going right now. Alright, have the full-size CRT partially reinstalled it and put the mounting strap on it yet, but I do have it plugged in. So let's fire this up, see how it works. I want to talk a little bit about how I'm feeding a signal into this set right now. So we haven't had the greatest reception so far, but I think it's how I have my signal connected up back. Alright, cool. So I did put a mark on there about where the ion trap magnet goes. So yeah, that seems to be about right.
1, 2, 3, 8,
We have good sound.
1, 2, 3, 8, 3.
48% of Americans aren't getting enough.
Looks like the sound is off a little bit from the best picture though, but
High absorption magnesium glycinate.
some of these split carrier sets is a separate IF for video and for IF. And not every, I'm using an over-the-air converter box, so not all created equal.
Out my account and $30,000 is missing. $21,000 just gone.
Every 5 seconds.
Alright, so image isn't quite, it's got a lot of interference in it. But now I'm wiggling around where I have the signal coming in, and it's definitely having an impact. So let me show you how I've been fitting signals into sets lately. Also, I got to admit, I know it's insane, but it's so tempting to just reach out and touch that, just to see, just want to see. But yes, I actually have done that once or twice on one that wasn't fully energized, so I know what it feels like. But man, having this outside the cabinet and even just going close to these knobs, anyways. Okay, so back in the day, they had these little gizmos, kind of look like clothespins, that are actually really handy for feeding signals in. So it's on a spring, we got a screw terminal on either side, and then these metal claws that have teeth on either side and on the end. Well, those are for going onto antenna terminals. It's a handy way to make a quick connection. So a typical antenna terminal would look like this. You take these and they clamp right on. And then you screw a wire into either side, go into your signal source. And the ones on the side are for ones that are closer together, like this set has. So this is one standard type spacing for antenna terminals, but on some sets, Not sure if I have any in my little junk bin, but sometimes they're a bit closer together, in which case you can use the side. A similar idea to clip onto it. But it's not the greatest connection, especially like on this one where the screws are a bit rusty and you're just clipping it on like that. It's not as good as getting a signal in there directly. So here's a little jig I typically use when I'm feeding a signal into these sets. So got a 75 ohm cable coming from my signal source going into a 75 to 300 ohm balun that's screwed into one of these guys, and then I'm clipping it onto the set. Well, one, I just noticed that this wasn't fully tightened down, and I know the terminals on that are a little corroded, so what I want to try doing instead is take another balun and screw it directly into the tuner after I take a little brass wire brush and clean up those terminals, and then we're going to screw this into it and see if we get a clearer image. I tell people time and time again when they're working on these sets and they have problems where there's weird interference on the set, it's not great reception, a lot of people, they start diving into the tuner, changing out tubes, checking things. Check your signal source. Could also be your converter box is weak. Like I said, not all these are created equal, and some of them are getting to be pretty crusty, like 20 years old. They might not have the strongest output. They might not be perfectly on the frequency with these sets. Sometimes, especially with these split carrier sets, they weren't so great about suppressing sidebands or bleeding over into adjacent channels. Or just the RF amp could be getting weak. Electrolytics in these could be going bad. So if you can, try a different signal source. Check your connections. Tighten everything down before you start troubleshooting and digging into the tuner. Also, not all baluns are created equal. That's what they call these balanced, unbalanced transformers, balun for short. I think I got these off of Amazon, maybe, from China, and these I got off of eBay. These are new old stock. These are more current production. This is heavier. This has thicker wire. This has beefier spade terminals on it. This, not so much. I even had a colleague who was having trouble with one of his, and he busted it open, and it did not have the proper matching network components inside of it. So if you can, get some old ones from back in the 70s or 80s, from a cable TV system, whatnot, that like Gerald or something, like name brand, quality baluns. Yeah, the antenna connection most definitely makes a difference. I think we can all agree that looks a whole heck of a lot better now.
Normal forward approach procedures, Mr. Sewell. Captain, Mrs. Fox, still thinking about Trelane, isn't it?
I think we got it. I think we got it. So that would be the expando mode, and that would be the normal mode.
Embodied energy, super being.
It's really, really, really beautiful picture on this set.